So, packaging. It's why you're all here. It's what this presentation's about. What it is, though, is the fine art of turning your code into a self-contained artifact, or in other words, a file, right? You want to get your code that you worked so hard on down into one little package. That's packaging. So, and then you want to take that package and send it over to some form of production environment. That production environment might be a data center, like what LinkedIn runs in, but it also might be a laptop or a phone. You know, if you have an app, the phone is your production environment. You know, we all use them. We should respect them. It's not all about big data center stuff. Okay. But the question is how? And that's what this presentation is about. How do we Pythonically package Python software? Let's take a look. So, true story, the very first project I worked on at PayPal, and Aniruddha here knows about it, these were the packaging instructions that I had on the Twiki page way back in 2009 when we used the Twiki, and aka FOSWiki. You know, we figured it didn't make any sense to work on the packaging part of the document until we actually had some code. First we'll write it, get it working, then we'll figure out how to ship it. We'll worry about all that stuff later, right? Don't buy the box until you have the item. Makes sense? Well, that was a disaster, right? And in reality, right, like, you know, basically a lot of developers leave this packaging till the end. Make the same mistake I did back in 2009. And they discover, you know, when you actually leave it till the end, you discover what feels like 1,000 options, right? It's a very big landscape out there, and you don't really know what's going to work for you. So, of course, you do the natural thing, and you invent one more, right, very last minute after your project is overdue, and then you ship that, much to everyone else's chagrin, you know? And then you leave the docs for that TBD, right? That's for the next guy. That's Aniruddha shipping my software now. All right, so let's see. So basically, I want to call to your attention this very old sort of rule of software, which is that the first 90% of the code accounts for the first 90% of development time. And guess what? The last 10% of the code accounts for the other 90% of the development time. You know, and this is going back all the way to Bell Labs, Tom Cargill, right? And it got a name. It's the 90-90 rule. This is why software runs over, right? Everything's going on schedule. We're green until the last 10%, and your project manager starts sending emails that, oh, this is at risk, this is yellow, you know, and they start hiring more people, but it's too late. It's too late. So, the 90-90 rule. My theory is that actually a lot of that last 10% is probably packaging, operationalizing, productionalizing, whatever you want to say. It's getting that last little bit ready for the production data center. And what I want to say is, like, if you come away from this talk with one lesson, it's that packaging is not the last step. I look out there, I think a lot of you probably know this, but your production environment is everything. Think about that. Know your production environment long before you get into the meat of writing your application. If you can't answer that question, you probably should spend time on that first. Send those emails about being at risk earlier. You don't know your production environment. That's the real risk. All right. So I think I drilled on that enough. So, oh, right. So actually this is the portion during which I do a live coding demo. So can you guys see my terminal okay? Is it showing up there? It's orange? No, you should be seeing. Well, it's too late now. I've already finished writing the code. There's a reason they brought me in. The code, it's ready, and it's ready to be shipped. And it's named useful.py. It's a good name because it's a very useful piece of software that I just live coded here. And I'm going to deploy it in the best way I know how, which is I'm going to securely copy it using SCP to the destination host. And once I get there, I'm going to run it using the best programming environment that exists, which is the Python programming environment. So I'm going to run it Python useful.py, and it's going to be great. You're going to love it. So yeah, come over here, run my code. Oh, wait, just a second, guys. I mean, this machine, it's a new machine. We just provisioned it. The bash RC is weird, right? Like the Python. Okay. Anyways, let me fix that. Oh, okay. wait, I'm getting an import error. Like, this was working a second ago. This worked on my machine, I swear, right? Like, you just saw me write it. It was working. I tested it, obviously, before I deployed it using SCP. So it was working on my machine a second ago, but, like, give me a second. Okay, I fixed that. Oh, boy. This one, what is going on here? I ran Python. Now I got SSL certificate errors. It's giving me some C file. It's talking about ASN1 like I'm, making a satellite in the 70s. Like, who uses ASN1 anymore? I thought everything was Avro, right? Anyways, but the point is that for some reason, Python has betrayed me in this moment. My deployment, my packaging, it has failed. It's failed us all. I feel very bad. This is what we don't want to happen. This is why we're all at this talk. Here's my very useful script. It's a very useful script I use to check the status of the most important page on GitHub. So that's my profile on GitHub. And it's going to just make sure it's up so you can get to my software, right? That's the most important thing to me. But this very useful script, this very useful.py, is only 3 lines long. And if I'm going to get that kind of error when I deploy to just a single host, right? What kind of programming environment is Python? We really need to learn how to package and deploy Python better. Well, lucky for you, there's a meetup that's happening, right, very close by. And and for that meetup and for other conferences and so forth, I prepared an analogical sub-presentation about how to get there. It's called the packing gradient. Sort of like the packaging gradient, but for packing suitcases. All right, so this is the one I gave in August 2017. Just imagine yourself being a conference crowd and not being from right around the corner, but I think it still works. Question is, how far are you traveling here today? If you're me, you thought you could get here from North Peninsula in under an hour, and so you just drove, right? But I brought my car because, Caltrain's not close to this building, is it? So basically, I brought my car. I was traveling a little bit further. Right? The idea behind the packing gradient is that how far you travel influences what you're going to pack. I got my bag here, right? My Wikipedia bag. But if you're only coming from that building over there, you probably just brought your wallet. You gotta be able to scan into the building, right? If you're a LinkedIn employee. But if you came a few miles, you probably, like me, brought a backpack. And if you're coming, hopefully you're not traveling from, too far outside the Bay Area for BayPiggies, but if you are, welcome. Hope you enjoyed the 101. Anyways, you might have bought a carry-on bag on your flight. If you came inside the USA, you probably have a suitcase. You check your bag. You like to pack a little heavy. And if you pack heavy enough, you might bring an RV because it's a great American tradition. And finally, if you came up from outside the United States to join us here tonight, well, very much welcome, especially with the travel complications that are happening. You probably brought a passport, so how far you came from influenced what you packed. And so what I want to sort of draw the analogy here is that at the top, if you're not going very far, you have a nice low size for your wallet, for your purse. And if you're coming from very far away, then you have to be highly portable, aka compatible. This is something I learned kind of a while ago. Do you know what porting software means? You probably have heard of the term porting software, oh, I ported this. You're always waiting for your favorite game to get ported to Linux so you can, actually play it because you don't have a Windows machine anymore because Cortana is going to do things to you. Anyways, so basically porting something comes from this term, I guess, used among campers when they carry a canoe between 2 different lakes. That's what porting is. I didn't know that word until someone came up to me after the first time I gave this presentation. So that's where portability comes from. But I don't want to confuse you with actual portability of a backpack. The heavier thing is more portable because it works more places. That's compatibility. Portability and compatibility. But you'll notice the most portable thing is a suitcase is actually not very portable physically. My analogy breaks down a little bit. So let's see, the packing gradient, distance and accommodations. Think about that production environment. Where are you staying, right? If you are staying in a hotel, you brought your suitcase, right? But if you brought that Winnebago, you're probably staying in the Winnebago. So you probably just park on the street, rent-free. This is the Bay Area. We see these back streets and so forth. That's the best real estate in the whole valley. Anyways, just living the American dream. All right, so I think you get the point, though. Distance and accommodations determine what you pack. Next time you're packaging software, keep this analogy in mind. What does this look like for software, right? We want to get back to our regularly scheduled program now. You came here for software, not my travel advice, right? I'm not, what do you call it, tripadvisor.com, giving you a guide to the Bay. All right, so we want to ship Python software. And the smallest version of Python software we can ship is the standalone Python module, right? That means it's a single py file. This is sort of just, technical terminology, but a py file is a module, and a module is a py file. There are corner cases to this terminology, but I think we all are familiar with that much. It's standalone. This is sort of a term that I'd like to introduce. That means it only imports from the Python standard library. That means basically, especially if you're doing Python 2.7, anywhere you have a Linux version going back almost a decade, you can run it. If you just build on like 2.6, 2.7, it's very, very portable. It's part of the Linux standard base. It's on most Macs, right? It's even, starting to get a little prevalent among PCs and Windows machines because of the amount of data analysis that happens on them. So, some examples of this. There's a lot of precedent in this for the Python world. The favorite one of mine is bottle.py. It's a single file web framework, and it inspired Flask, right? I don't know if you know the story of Flask, but wait, who here uses Flask? Okay, like a lot of you, right? Like, if you know the story of Flask, what happened was Armin Ronacher got sort of frustrated that bottle.py was taking off, right? When, he had Werkzeug. It's this amazing WSGI toolkit that he worked so hard on. And he's like, well, you know what? Anyone can do that, right? I'm just going to take all of Werkzeug, turn it into a zip, base64 encode it, put it into a single file, and hey, I have a Flask now. It's a bottle, right? A single file. That's what you want, right? And it took off. People actually liked his little, April Fool's joke of a web framework. It was an April Fool's joke. And before you know it, now Flask is born. Now so many people use it for so many things. But bottle.py got it all started, and the documentation for bottle.py is longer than the code itself because it's just one Python module. So it's a pretty cool thing. I followed that example, and I've written a bunch of such modules. The most popular is in a batch called bolt-ons, but I also have a templating library called Ashes, which, because it's linked in, I'm going to say Ashes is the Python implementation of Dust.js, if you guys know Dust.js. So anyways, but that's still been pretty handy. And finally, there's schema, which is something I've been using a lot at work lately to do basic validation of recursive structures and so forth. Highly recommend checking all of those out. They're all on GitHub. But the key is that the standalone Python module is easy to distribute and integrate. You write the Python, and it's ready to go. Pretty cool. In fact, it's so cool that people will take these and they'll move them into their actual code base, right? The easiest way to distribute something is if you don't have to distribute it at all. It's part of the thing that you want to ship. And so that's called vendoring. Including something in your software that you didn't write is called vendoring. We'll probably be mentioning this a little bit more. So, our next phase, the next level of Python packaging. It's the pure Python package. Basically, this is a directory with a dunder init inside of it. Dunder init.py. I know when I first started Python, I'm like, why do I have to have this empty file in there? It turns out you can put stuff in it too, and that works. Yeah, so whether or not you put stuff in the dunder init.py, that directory is now effectively a Python package, and you can import that directory's name. Again, I'm pretty sure most of you have done this. But examples of this would be like Django or requests. They're written in just Python, and they have directories with Python files inside of them. Pretty straightforward. That's kind of the default if you've been doing Python for more than, a week. So, yeah, basically, and the last one there is hyperlink. That's a library I worked on, twisted URL stuff. I presented it at one point at the BayPiggies in like a lightning talk format. Anyways, pure Python packages, best way to get them, you get them with pip, right? People here use pip, I assume, unless you vendor everything. It has been done before, so you get your Python packages with pip. And that's because pip installs packages. I presume. That's sort of a backronym of sorts. But it's a little bit more complex than that. Pip doesn't actually install packages. If you'll pardon my diss for a moment, a distribution is actually the archive that pip downloads and goes and finds packages inside. And you can even have a distribution that doesn't have packages inside, that only has modules. So it's sort of a hidden detail in the Python world because we have the Python package index, not the Python distribution index, right? Python package index sort of rolls off the tongue a little bit better anyways. So, but basically you build a distribution of your packages and modules using setup tools and a setup.py. Who here has written a setup.py? Good, good. So a setup.py basically will turn a directory with those directories I talked about, right, with dunder and init.pys, into something like a zip, a single file. In this case, it's a tar.gz, and it's called an sdist, which is source distribution. And it's very simple. It's just, as you know, like you've tarred up the directories and you've gzipped it. So this is great for those pure Python modules and packages that we were just talking about. And here you can sort of start to get a sense for the nesting nature of the packaging gradient I'm trying to get at, which is that single Python files can go into packages. These packages can go into distributions. Distributions are then distributed, right? So things kind of nest. So look for that matryoshka nature as we move forward. So why do distributions exist? If we have the Python package index, and really what we want to install is requests, and requests comes as part of a distribution that has basically just one package inside of it, why have this extra layer of distribution on top of it? Well, one, like I said, it digests all those files down to a single file that you can redistribute. But very interestingly, and this is one place where Python doesn't get enough credit, you can have multiple distributions providing the same package. And a really great case for this is if you've ever done image manipulation in Python, there's a thing called the Python Imaging Library, PIL. PIL, it's right up there. And so basically, but it's kind of a bitter pill these days because basically nobody has been updating it for a few years. But we still got to do image manipulation in Python, and there are all these crazy formats we have to support and new features we want to add. So someone came along and forked it and made a thing called Pillow. That's a nice soft name, It's not like a tough pill to swallow. It's like I'm going to take a nice nap and just dream of beautiful image manipulation. And so Pillow actually has the pill package inside of it, but a different name for the distribution. So theoretically, if at any point you're uncomfortable with the way that somebody has treated their code, you can fork it and re-upload it to PyPI under a different distribution name, but the same package name, and you don't have to change any of your imports. That's pretty cool, I think. If you don't think that's cool, then you should probably go learn a little bit more about what happened with like LeftPad and what happened with like, Go having GitHub URLs in there and then GitHub goes down, that sort of thing. Basically with this, you can have your own overlay of PyPI. That's probably a different talk, but you can use something like, what's it called, DevPI or something like that, and provide your own distributions that have these packages in them, and you just move on. Not even, it's a tiny little speed bump. Just keep on rolling. So Python has these distributions, and they don't get enough credit. That's my take there. But we still haven't unlocked the full power of the Python package. The full Python package has to encapsulate Python's interoperability and performance. So one thing I have always been saying, I've always sort of had to kind of argue against, is that Python is slow or something like that. Or it's not enterprise for whatever reason. The fact is that Python interoperates with C, Python, Fortran, all of these highly performant languages, and you can sort of bring them together under one very high-level roof in a way that you have overall, holistically, a much more performant application. So Python's interoperability and performance is absolutely key for its overall strength. So Pillow, our example that we just had there, it has parts of it implemented in C and C++. NumPy, basically this basically the same thing. These, I think, like, Gevent and this crew here, they have a lot of C, they have a lot of Python, and that's what makes them so fast. And you can't say that NumPy is not Python. It's one of the best, fastest number matrix manipulation libraries out there, and it's wholly Python, even though parts of it aren't written in Python. So the full Python package actually includes more than Python. And for this, we need another format. Because the fact is, if we distribute this as an sdist, you're going to get C and Python files, not just like Python files. And it's not going to work right out of the box if you just unzip it into site packages. So finally, after years of dealing with other formats, we have this thing called a wheel. And I'll explain the name real quick. Yes. So first of all, the wheel is a binary distribution. It has the built artifacts inside of it. We built the SO, we built the C, we built the Python, and we have this binary artifact, and we put it into the distribution. That makes it a binary distribution, or bdist. We have sdist for source, bdist for binary. Now, it's, and it supports most Windows, Mac, and Linux setups. Windows, pretty good support. Mac, pretty good support. Linux, a very complex landscape, and we have the top guys working on it, et cetera, et cetera. We support most things through this standard called Many Linux 1, with number 1 in case we come up with something better soon. Okay, so with wheel, I should mention it's called that because PyPI, the Python package index I was mentioning earlier, is frequently called the cheese shop. If you've actually watched Monty Python, there's this cheese shop sketch where John Cleese walks into a shop, repeatedly requests different varieties of cheese, is told that they are fresh out, just ran out, etc., don't have it, never had it, etc., and turns out it's a very clean cheese shop, right? But the Python package index is a much less clean cheese shop, and we have many, many wheels of cheese inside of it. So the wheel format comes from this Monty Python sketch. Anyways, enough with tomfoolery. Okay, so the wheel format replaces an egg format, and those two things together make a delicious omelet, but right now we just want cheese, we just want wheels, no more eggs. Eggs are to be forgotten. All right, so, okay, before we move on, I gotta talk about linking. This is where things get a little bit more complex. So there's this thing called static linking and dynamic linking. Who here is familiar? Okay, so like a lot of you have clearly written more than just Python, because if you only write Python, you aren't going to worry that much about linking or the linker or LD library path or any of these fun things that go along with linking. I'll do my best to give a brief explanation here. So all of those C files that we might get in an sdist and that we get in a built form in bdist are going to rely on sort of a variety of things on the operating system into which they're being installed. The more it relies on from the core OS, the more dynamic its linking kind of strategy is. You can build more stuff into it, thus increasing its self-containedness, and then you'd have a more statically linked artifact. And the whole linking process is basically about having certain SO files and A files and headers and so forth laid out on your file system under the lib path and that sort of thing. We don't need to get into that detail quite yet, but for the most part, what I want you to remember is that statically linked artifacts are more independent. Dynamically linked artifacts depend on more to be provided from the host production environment. So to this end, I say some wheels are bigger than others. Technically, not all wheels are going to have the same reliance on your host system. If I just make one little C optimized file, one little Python file that does a little hash for performance reasons, it's basically, the bdist that goes out is as independent as almost like an sdist would be. However, if I have something very, very complex that uses like OpenSSL and all these sorts of things, I get to decide if OpenSSL comes from the operating system or if I statically link it in to my distribution. And so basically some of these examples, if you've seen DLL files if you worked with Windows. If you work on Linux and Mac, you'll see more SO files. I think that No, we didn't have, if we go back to that, like, OpenSSL error that we saw earlier during my fantastic deployments, basically, that is coming from an OpenSSL SO on the host system, more or less. All right. So libcrypto is what usually gets linked in. That's not even a joke. I just stopped the sentence at the part. Okay, but in fact, like linking things in is like all. Honestly, I think that LinkedIn may have got its name from back when this at PayPal and everything was linked into one giant executable. Anyways, so yeah, but so examples of other system libraries that you might have to deal with are like libxml2. So if you ever had to deal with LXML, you know that you have to install libxml2 into your host system first, right? It doesn't necessarily statically link that in. But if you Google it, you'll find instructions on how to create a statically linked LXML, and you'll also get a free complimentary headache along with it. And libpng is something Pillow might want for handling those PNG files. And if you really want to be someone else's pain in the neck, you can link in libpython to your wheel and make everything break. Probably don't do that. Probably don't do that. I'm not sure what would be the consequences of that, but I think it's technically possible. I don't think PyPI will stop you. All right. So that after our little deep dive into linking there, just to recap, Python, setup.py, sdist, bdist, wheel, upload. This is the modern way to build and upload a Python package, right? We use Python, we got our setup.py to get our setup tools, right? And then we get sdist, which is our source distribution that we want to upload, and it builds a tar-gz. We got our bdist wheel that actually builds a tar-gz of the built artifacts, straight zipped out of like site packages, and it uploads that to pypi.org, the updated version, warehouse. This is the modern way to build and upload a Python package, right? Hopefully, basically, that has been enough slides to fill the time. I don't know, Jeff, how are we doing on time? 7:44. Well, I mean, we can have a long question session, right? Like, I hope that you guys have some questions, right? You got some questions? Okay, so because like you better have some questions because all we've covered here so far is like how to do Python libraries. And if you read the Python docs on how to do packaging, you're only going to read about like how like setup tools does stuff, how you can make an sdist, how you can make a wheel. It's not going to tell you how to ship most types of software, right? When you go to deploy LinkedIn and maybe you have a release engineering team or some sort of CI configuration or something like that, like you don't just build a wheel and like drop it on a Linux server in the cloud. Is it in the cloud? Do you have a data center? You got data centers, nice, okay. Keeping it old school and economical. All right, but the point is that wheel won't let you install most types of software, right? Like when was the last time you installed a wheel on your phone, from an app store? That doesn't happen. Python's native package management gets you libraries, dev tools like pip, and maybe Pelican, which is good for like blogging if you're a developer. But that's basically it, right? Like you can use Python's native package management and PyPI and this sort of stuff to get you dev tools. It says Python package index, but not all kinds of Python can go on there. Because Python is general purpose, right? No one packaging solution can contain all of Python's power. Right, this is basically just a long list of things that I've seen Python used for, and I bet you could add to it. But we got telephony, we got payment systems, we've got neuroscience, we've got numerical analysis and engineering and matrix and all that stuff. And then we got animation, LucasArts, Disney, DreamWorks, Lytro. I'm not sure if that's what you guys do. But basically we got gaming backends, right? Second Life, EVE Online, Battlefield. We got email infrastructure like Mailman and Mailgun and Mail, all sorts of other things. We have media storage, YouTube, maybe you've heard of that one. If not, maybe Instagram, or maybe you just use Dropbox for everything. If so, right, you've just used a lot of Python. Operations, system management, Rackspace, OpenStack, natural language processing, machine learning, security and penetration testing, big data, calendaring, search systems. Python is very general purpose. And when people start talking about, and also DNS, although let's not talk about that one at the moment. Anyway, so basically, when people talk about how Go and other solutions are really, really like easy, built-in packaging solutions, it's because oftentimes those programming environments are not as general purpose. You can't use it for all of these things. Python has a lot more applications and has found its way into all places, all sorts of production environments over the like 26 some years that it's been publicly released, especially in like the embedded space, which I didn't have room to talk about here. So the point that I want to demonstrate is that PyPI can't be an app store for all of these things. And in fact, it's not an app store at all. It's free for one. But Python is general purpose, but pip and PyPI are not, right? They talk about packages, but really they're talking about specific development packages like libraries and dev tools. So why is this? Well, it's because pip has some pretty high requirements. You may use it often enough that it doesn't feel that way. Like everyone says, oh, just pip install my library. But really, pip requires a working Python, right? We take it for granted, but not all machines have it. You need a working Python with pip installed. And maybe you have to easy install that pip, or maybe you use get pip and you use curl. And, like these things are muscle memory to us now. And we do them so quickly, but that's still a requirement. You need a network connection almost all the time, unless you have a handy like flash drive with a bunch of wheels on it, right? You're going to actually need to be connected to PyPI to get those packages. It also needs pre-installed system libraries. A lot of things like LXML, you have to pre-install libxml too. And maybe you have that on your image and it feels so natural, but a lot of environments don't have that. Someone put it there. And you need build tools. Like I talked about wheel, but a lot of people still aren't doing wheel. A lot of people are still just putting up sdists with their C files in it that have to be compiled when you pull down the distribution, in which case you need GCC or Clang. And you have to sort of have years of experience running Arch or Gentoo or something like that to deal with the subsequent output. So, but the biggest thing, oh, right, for when wheels aren't available for your platform. But the biggest thing that pip actually needs, and this may surprise you, it's you. Pip's most important dependency is you. That is, a developer who is willing to sit and watch those dependencies download one after one, and then if your internet gets disconnected, to resume it, and then basically debug any version conflicts, build errors, and all those sorts of things. We take this for granted, right? But it's not acceptable as an install process, right? To basically just say, hey, go pip install my package, mom. Right? Like, you want to use my software, mom? I got it for you. I put it online. It's open source. I know you'll love it. Just, open up your terminal, pip install my favorite mom dot, wheel. Anyways, yeah. So, the question is, and, basically sort of my joking early termination of the presentation was just the prelude to this question. How do we ship applications, right? Applications like Sublime Text, that's a text editor written in Python. Eve Online, which basically has Python backend and maybe the front end too. It's a video game. And Reddit. Reddit is a big website that you visit through your browser, right? But I assure you they aren't pip installing those like server and microservices and other things on their backend in their data center or cloud or whatever. So basically the question is, when you look up Python packaging, you usually end up on pages talking about Python's packaging. And really we want to talk about how do we package Python? How are companies and organizations and open source folks actually shipping their Python applications as opposed to libraries and developer tools? But before I do that, right, I said there would be an interlude for questions. So if we have questions about libraries and these sorts of things, before we embark on the journey of applications, let's have a little powwow, right? If you have questions about what you've seen so far, hop on up. Yes? Great dependencies you. I see. So, right. So the question is, pip can be very brittle. So, I mean, I think that just reinforces the point, right? That you need to have a skilled developer to work with these developer tools, and we are totally justified for the sort of like, salaries that we pull down here in the back. I see. So yeah, the question I guess is for these open source libraries that we're downloading with pip, what is what should be our standard for what those error messages should be? So maybe you're saying that it's not acceptable that I have to debug GCC, right? For from installing a Python package. I tend to agree, right? Like but basically setup tools and all these things it's like on version, I don't know, 30 something, right? Like, not that the version number is any indication of the actual battles that were fought on the fields of Python packaging. It's getting better, I think, overall, especially as more wheels ship. Then you don't have to deal with the stuff as much. I think that the core Python packaging authority has taken a very direct approach to that sort of thing. And rather than telling people to have really good error messages and so forth, they're just like, how can we make it so these error messages won't occur at all, and ship the binary distribution, right? But no, it's a good point to make. Yes.
So you talked about pip and uploading things there. Normally when I'm trying to install something, you Google the package name and figure out, pip install this.
Mm-hmm.
Given the recent issue with actually verifying what you're downloading,
right?
Is there trade-offs there where you can be sure you're downloading the right thing?
Yeah. So the question was, how do I make sure that I'm downloading the thing I want, something verifiable from PyPI? Right? And in fact, we had a great talk at the Peninsula meetup for how Facebook does this. They basically run a mirror of PyPI, and they sort of audit things as things get put in. When I was at eBay, we ran a dev PI, and we theoretically had that same process for these packages. When I was at PayPal, we actually vendored everything. If you wanted something, we actually made it deliberately hard to get it. So, so you had to go through us, so we had to vet it. And that may not have gone over the best with some of the developers, but like when you're dealing with, something as dynamic as Python and something as freewheeling as Python, you can Google Python anything and you'll get something, right? Is it what you want? You kind of have to vet it. Now, as far as technical solutions for what you're describing, once you decide what you want, right, vendoring is a good option. You can vendor at build time, or you can vendor like for runtime too. Another thing is that you can use these like pip like lock things. So there's this thing called pip tools. And it actually vendored one of my projects, but it's pretty popular. It's by the same guy who made that Git flow thing so many years back. But basically, this pip tools thing allows you to lock things, certain artifacts to certain hashes. And so it will like throw an error if it downloads a artifact that doesn't match the artifact that you downloaded some months ago. Yep, and it'll keep hashes for all the platforms you need, because especially with these wheels, you're going to have a file per per platform plus Python version plus any number of other sort of dependencies that you might build for it, like NumPy, various versions of that, and maybe also like your Unicode width. Like there could be a lot of things. Anyways, yes.
You also need to get it to work. You need to install setup tools first.
Yeah, I think that get pip, so the question was like, in order to get pip to work, you need to install setup tools first, and yeah, that can be the case. Mm-hmm.
But then also you end up a lot of time in a production environment that doesn't have internet access.
Right.
So what you have to do is you have to get part.gzs, get all of those together, install.
Yeah, you can. So you have a good point. You can totally install from the actual files, and that's definitely something I recommend. Like, they have a good CDN now, but like it used to be that when you pip install things from the internet, it would be pretty variable in terms of the internet quality and how long that would take and whether the server was overloaded and so forth. So the CDN works pretty great, but the real way to eliminate that sort of variability and even some of your security risk is to have the artifacts you want in hand. Yeah. So let's see. More questions about libraries? Sean in the back? Uh-huh.
What's the correct blend of dynamic and static?
Okay, yeah, thanks for digesting that down. So basically the question is, what's the right balance of dynamic and static? And in fact, that's part of the special extended bonus edition that all of you guys are going to, have here in a few minutes, hopefully. But yeah, that is sort of like it's an aesthetic choice, right? It's totally up to you. There's not a hard and fast rule about it. It's about knowing your production environment, and we'll see a little bit more about how to actually do that. Other questions about shipping Python libraries? Yes?
For example, there was a great talk at Python about libraries.
Absolutely. So that's definitely the case. Like basically, if you're going to ship a Python library, always also upload the sdist, right? For people who have special needs, you want to actually make sure that you have the ability to just untar it and build those files yourself with the compiler flags that you want, with the compiler of your choice. Maybe you want to use Intel's fancified stuff. So, and I think Intel actually does that. Remember, like a lot of organizations build Python distributions. As you'll see about Anaconda and so forth, they're going to rebuild stuff from source and put special optimizations in there that you might not get if you just had wheels. And this whole talk about UCS4 and UCS2, the memory representation of the Python Unicode character, basically, can be 2 bytes or 4 bytes in Python 2 and earlier versions of Python 3. Now in later versions of Python 3, they've eliminated that, which increases compatibility, binary compatibility for wheels and stuff. That's a really concrete reason to use Python 3, in case anyone was wondering. Okay. I think we have time for one more if it's short. Okay. The CPU. Okay, so the question is, can you ship something where the user can decide to target their CPU or GPU or something like that? I think that there are probably some people who are a lot more qualified to answer that, especially when they're doing machine learning, Keras, all that sort of stuff. I'm still a novice in that domain myself. But as far as I can tell, some of those libraries at least appear to document that sort of functionality, and they, maybe it's something you have to rebuild and use an sdist for, or maybe it's something that they actually build separate shared libraries for and have a conditional import, depending on what your environment flag you set. But okay, so that's a pretty hefty discussion about libraries right there as an intermission. But if you're feeling refreshed, I think I'm ready to carry on. So, yes, just as a reminder, here is our script. I hate that term, script. A script is more properly termed a command line application. Call it what it is, right? It's an application and it runs at the command line. It's just 3 lines, remember, and it still failed catastrophically. If we treat it very sort of dismissively, right? Oh, it's just a script, just copy it, it'll run. You're going to have problems, right? So it's a command line application, and it's worthy of an actual, package, right? An actual application grade package. So these next few segments are all going to be about how do we ship these 3 lines of Python to all these different things using all of the industries and, open source world's best options, right? The best Pythonic options. Okay, keep these lines of code in your memory, right? Here we go. So the very first one I want to talk about, the lightest weight option we got, is Pecks. It's the Python executable, Pecks. And so I think this came out of Twitter, but it results in a single runnable file. It's open source, and basically you give it a command, and it will turn that 3 lines into a single file that, as long as it's got execute permissions, is going to do the most amazing things. It's going to visit github.com using HTTPS. It's going to tell you the status code on standard out. It's an amazing command line application. Really nicely, Pecks artifacts don't have a setup or install step, right? So in terms of like installation process, it's like 0 step. It's download the thing, I guess make sure it has execute permissions, and you're ready to go. So that's actually a really nice experience. We're starting to get to that point where I'm like, hey mom, open your terminal, wget this file. You have Python installed, right? It's not quite there yet, but at least when it comes to developer tools and a lot of these things where terminal is in the mix, right? A Python executable is a good way to go. So this builds on Python zip import, and I lied a little bit when I said we were done talking about eggs. But one good thing came out of Python's egg format, which is that Python can import from zip files. So you can have a single zip file, and you can call import on it more or less, right? As long as it's on the Python path, and it'll open it up and pull packages out of it, and it'll work. And that lets us build the Pecks. Something that did this before Pecks, at least I saw it before Pecks, is called Super Zippy, right? It's not as professional a name as Pecks. And now Python 3 builds in a thing called zipapp. This is a very bizarre choice. If you Google around, there's some blog posts criticizing this. But basically, zipapp is more or less Pecks, but with far fewer features. But it is built into Python, but it's only if you do like standalone Python applications. It doesn't really solve the issue of having external like libraries and so forth for you. Pecks is much more full-featured. But they all use the same concept, which is basically here. Let's look inside this Pecks. So if you open up your hex editor, someone should make a Pecks editor. But anyways, or a hex editor that's shipped as a Pecks. Think about that. Anyways, but if you open up your hex editor and you look at the inside of a Pecks, what you're going to see is, like, at the very top, a shebang, right? A shebang that says user bin and Python 2.7 in this case. And what that's going to do is it's going to open this zip file, as the rest of the binary sort of indicates, this zip file with the Python that is available on your system, on Mac and Linux. So, and basically, if you look really closely, you'll also see that there's like a bootstrap _ Pecks dunder init pyc. Inside of here, it's a zip file and it has all of your code along with Pecks' bootstrapping code, and it will run. You don't need a .exe extension or anything like that. When you're on Mac and Linux, as long as you just /useful, right? No py necessary anymore. It's going to have requests inside of it, and it's going to work great. So now it has the same constraints as Wheel, which is that you have to worry about static versus dynamic linking. We'll talk a little bit more about that soon. So, but to spell it out, and I'll do this for each of the options, the installation of a Pecks requires a system Python, right? You got to have Python on the system. If somehow you deleted Python from your Linux, or through some miracle, like had a Mac that didn't have Python on it, right? A Pecks wouldn't run. But there's also no setup steps. So the installation is copy and paste. It's really nice to get something totally relocatable. That really puts us on par with those Go static executables. In our case, the artifact is less than 3 megabytes. I actually built this, and with requests and all the dependencies of that, it was less than 3 megabytes, which I think is pretty manageable. You can build it to be OS specific. In our case, I don't think it was. I think that would be maybe relocatable to other machines as well. But if you had more wheels, right, then you would have kind of an OS specific thing, and your build pipeline would need to represent that. So yeah, overall, pretty similar to Wheels, pretty bound by the same rules as Wheels. But if you have something that you can build from Wheels, then a Pecks is a great option. The way we distribute Pecks is generally through web download. We have something a little bit like get pip, but get like my Pecks or something like that, and it'll just come right over curl and copy it into your path, and it works like a charm. I've even uploaded certain Pecks to our wiki. You can attach it there, and you can even just like drop it into your hip chat. It works pretty great. I mean, maybe use Slack or whatever, but people generally don't mind getting IMs from me, especially when I have like fixed versions of their software. So yeah, at work we use Pecks to ship the primary product that I work on. and it's really nice having all of these distribution options. So, in my opinion, Pecks is probably the right way to distribute useful.py. If you're writing a Python script that depends on stuff that's available as wheels, pretty much look no further. But, this is supposed to be a long talk, so I think we have to, actually look a little bit further. So, the next option I want to highlight is Anaconda. Now, Anaconda was a tough one to fit in here because it's not really a single solution. It's a whole ecosystem, right? You can kind of do a different way of development by having a better Python distribution. Now, if you've ever installed Anaconda, you don't go to python.org and grab the Python there, and you don't use the system Python. You go to anaconda.org, or you Google Anaconda and ignore the Nicki Minaj video, and you download a self-extracting bash script that is a pretty cool thing in itself. That's a neat bit of packaging I can talk about in a minute. But once you get it, you not only get Python, you also get this Conda command. And with Conda, it has Conda install. And at first I was like just using Conda install for all the same things I use pip install for, right? I just Conda install requests, Conda install hyperlink, Conda install ashes, whatever. But then I realized you can Conda install applications. Like I can Conda install Postgres, right? You can't pip install Postgres. Being able to Conda install a whole relational database, I can Conda install Nginx, right? I can have like a web server that's not written in Python, but still pretty neat for various other reasons. I can actually Conda install Python itself. If I don't like the version of Python it came with, which is 2.7 or 3.7 or 3.6 maybe, but basically if I don't like that one, I can Conda install another Python that will live alongside that Python. So this starts to get kind of circuitous. This kind of gets a little bit confusing, but trust me when I say that it's an ecosystem you want to know about. It builds on existing Python features and existing operating features and extends it in this very sort of Python-specific way, but not too Python-specific. Because, like I said, you can Conda install Emacs. You can get real applications, unlike with pip. So the features it builds on are the file system layout and a little feature of Python I call Python landmarking. And I'll explain what that is in a moment. Also, it uses some cool stuff like patch elf. It's not like a little elf that goes around sewing your jeans. It's like something that modifies executable formats. So here's what Conda and Anaconda looks like inside. So when you download that bash and you run it, and the setup runs, it by default installs a directory into like your home directory called like Anaconda 2. And inside of Anaconda 2, what you'll see is something that looks a little familiar. If you've ever looked inside of a Linux file system, a Mac file system, at the very root, you'll see that there's a lib and a bin and an include, right? There's an etc. There are these directories that basically mimic that of a Unix file system. And so when you're installing applications, everything lives inside of this Anaconda directory. It doesn't touch the system. It installs everything into this Anaconda directory under these like sort of Unix-like directories. And then what happens is that when Python runs, Python doesn't say, oh, jump all the way to the root of the file system and look at lib there to get my site packages. Right? Instead, it looks up relatively a couple of steps and just goes under this lib and grabs things from this lib's Python 2.7 site packages. So it's sort of self-contained in this fashion. I'll demonstrate. So let's talk about linking again. This is the special director's cut. So like I said, Anaconda provides some special sort of self-containment through this very standard feature. There's no magic here. It's just another directory. If you delete that directory, Anaconda is gone, unless you modified your bash RC to add it to your path. But like other than that, like you can just delete it and it's gone. So it has some intentional dependence on the OS. It's not completely self-contained. And to demonstrate this, I'm going to use another command line application, basically the same as useful.py, basically the same. It's called xz. It compresses and decompresses xz archives. It's actually much more complex than useful.py. Anyways, so what this does is it compresses and decompresses these files, but to do so, it relies on system libraries. And if we look at which system libraries it relies on using the LDD command, which stands for, I think, link dynamic dependencies, it needs, for instance, libc. Do people here know what libc is? Basically, libc is like where, all of these standard operating system features get dumped. If you need to use kernel features like allocating memory and all those really, really core basic things, you usually go through the standard GNU implementation of it or muscle or something like that. But so for that, it gets it from the operating system. For everything else, like libLZMA, which is a compression library, it gets that from my home directory with Anaconda 2. And it has this relative, you see that ... It has that relative import that we need. It's not an import, it's a relative dynamic link. It's kind of like imports in Python, but it's happening at a much older, more fundamental level. So here you see that basically XZ depends partially on my operating system, Ubuntu in this case, if you couldn't tell from the default purple of the console. But basically we have the, like libc coming from Ubuntu, but the libLZMA, that's coming from Anaconda. So in this way, it overlays on top of your system and mostly relies on its own stuff, leaving your system more like sort of clean and leaving your applications kind of more independent. So the Nginx you install, the Postgres you install, is going to pull a lot of its stuff, except the most fundamental stuff like libc from that Anaconda. It's a little... Yes, if this wasn't technical enough, it's using rpath with origin. That's the official terminology. It's a little bit hard to Google, and frankly, most of the time, I'm very happy to let these guys do their job. Anaconda is working really well. So basically, I say for fun, if you haven't heard of this list dynamic dependencies LDD tool before, it's on pretty much every Linux machine, maybe Macs too. I think Mac uses OTool for it. So O'Toole-L, yeah. It's not like the Irish last name. It's O-T-O-O-L, no E, no apostrophe. Anyways, so O'Toole-L. But on a Linux machine, run LDD on a random binary. See what you get. You'll see what things are inside of that executable and what things it relies on the outside for. You can run LDD on Python itself, and you'll see that Python, in order to run, uses a dynamic component called libPython. Remember I was saying don't put libPython in your wheel? That's why you don't put libPython in your wheel. It'll probably mess things up. And then also, Python's many libraries. So for instance, SQLite 3. SQLite 3 is SQLite's written in C, and SQLite 3 has C components. OpenSSL's integration with Python has C components. If you want to see those dependencies of Python's, look under your lib Python 2.7 libdynload, dynamically loaded, libraries, and start LDDing SOs under that directory. And you'll find some interesting results. You'll find that Python hooks into all sorts of things. So, an example of this, if you can read it, is Python's built-in SSL module here, at least for Anaconda, right? You'll see that libSSL, libcrypto, and libPython 2.7, these all come from the Anaconda, but we're still getting like libutil and libc and so forth from my operating system. So this is sort of melding and enhancing your overall Python runtime through this nice overlay that uses the operating system features like rpath with origin. Okay, so back to Anaconda itself. Just to refresh, right? You can use Conda to install applications. And on that note, I just want to reiterate here that you don't need to know all that stuff under the scenes to know that Anaconda is awesome, right? Basically, it is a cross-platform, Python-first package management system and social app store. I mean, I'm up here, I'm on the stage already. I might as well pitch you on something. I'm not getting paid by Continuum, but like it really, really is cool, and we need to be very proud of it in the Python community because this is I figured like, hey, there are all these package managers out there. They all do an amazing job at what they do, and so of course there's going to be kind of like, surely they must support many platforms, but when you really think about it, right, you can't apt install something on a Mac. Really, right? Like, Yum is tough to get working on anything but like that set of Red Hat and so forth inspired distributions. So this is what I found in terms of things that fit this description without the Python first part, just cross-platform package management. We have Steam, which is weird to think about. If anyone plays games here, right? It's weird to think about Steam as a package manager when you're just like, opening it up to have some freewheeling time. But basically, Steam is a package manager, and it is cross-platform, and that is really, really cool. And if you think Steam is cool, you got to think Anaconda's cool. If you've heard of these other two, right, we should chat after because that means you're like a real geek like me. And anyways, you like package source. And does anyone know what the blue one is? Nix. Yeah, it's lambdas. It's not wise, I think. Anyways, it's Nix though. Yeah, so basically Nix is cross-platform and it's like also functional, and for people who really believe in it, it is really the best thing. Leave the question to me. Okay. Anyways, so basically, to reiterate, like you can go on anaconda.org, you can make an account, you can have your own packages uploaded there, share them with people, star them, all that stuff, and they're going to host it for you for free, give you all of that bandwidth, right? And you can have this effectively like a social app store. The thing that we sort of think of pip and PyPI as potentially doing for us, Conda and Anaconda.org are doing it for us right now as I stand in front of you, and you're all paying very close attention to me. Like, at least one of you should be Conda installing something now, just to experience the awesomeness. Anyways, so yeah. Okay, enough of this aside about Anaconda being awesome, and you get the point. Let's look at what our app, our useful.py, looks like on Conda. So for here, the installation requires Anaconda, no joke, right? But it will work on Linux, Mac, and Windows. It's truly cross-platform. And you do a Conda install to get it, right? So there is an installation step, unlike with Pecks. With Pecks, it's just drag and drop, but with this, you do Conda install it. The artifact that is downloaded is less than a megabyte. And that's because it can do dependency resolution and transactional installs. So basically, I don't need to include requests. There is a version of requests that my package can depend on, and it will be installed effectively as one step. And it fixes a lot of that brittleness our friend over there was worried about with pip. It's OS specific. So I can have like individual artifacts for different operating systems and have my feature flags and so forth. And the artifact itself is a tar BZ2. It's really, for 3 lines, it's going to be like kilobytes. It's going to be very tiny, maybe smaller. Anyways, and for distribution options, like I said, you don't need to look much further than anaconda.org. You can ship that tar BZ2 around. You can use conda install to install a specific BZ2. But realistically, it's very convenient, especially if the code is public, right, publishable. You can just put it on anaconda.org. It's free, and other people can just grab it from your channel. So Conda itself is a good channel for distributing our tools to devs and data people, right? Remembering that production environment, remembering who your audience is, the data people that are using Anaconda are now basically also going to be able to install your application. I feel more comfortable telling someone to Conda install something than to pip install it if they aren't really a full-time, or at least most of the time, developer. All right, so things are heating up or cooling down, depending on how you want to look at it, because now it's time to talk about freezers. And our chili snake friend there is basically an artist representation of a frozen Python. And it's a strange name, but this is how you build Python into your application. So for the last 2 options, Pecks, you need it from the system, and Conda, you brought a Python in the whole ecosystem, but the application itself didn't include it. Let's say you're targeting a Windows machine, especially like a laptop or a phone or something like that, something where Python isn't installed, something other than the Linux and the Mac for once, right? In this case, you basically have this as your primary option. It usually means that there is an installer involved. So basically, like, there's a setup right? And then there's a wizard or something, right? Or you drag and drop with an app. There's some aspect of an install step. My favorite example of a frozen Python application is Dropbox. Their front end, like client, basically, is written in Python, and in order to ship it, they have a Python runtime in their artifact. EVE Online is another example. Civilization 4 actually embedded Python, which is a kind of freezing. It's a very large C++ application for the most part. But Kivy, if you've heard of Kivy, is sort of like Qt or something like that, but it includes this packaging element and lets you get applications for phones of all varieties too. It's kind of like Unity, but for Python and not for games. Anyways, so yeah, basically we have a lot of options in this freezer space, and that should tell you something. That should tell you that this is one of the more complex things, but we have more options than I could list as bullets. So CX freeze, PyInstaller, OSnap, BB freeze, Py2exe, Py2app, PyInsist, Nuitka, Constructor. It's a very long list, and I have one on my website if you want to really have clickable links for each of them. But all of these things effectively build your application and Python melded together into one file that is typically pretty OS specific. If you look at Py2exe, you can probably guess that's going to build a Windows artifact. Py2app, that's going to build a Mac artifact. This is how you get Python onto those consumer machines. So if we want to get our nice GitHub status checker deployed onto one of these sorts of machines, we could freeze it, but we need to freeze a separate artifact for Linux, Mac, and Windows, probably using different libraries for each of those. So we can do an executable in some cases, or one of those double-click installs. And it does rely on system libraries in many cases. We're back to that static dynamic linking. This is really a gradient here. How much do you want to build in? How much do you want to rely on? Have you ever tried to open a Windows application maybe some years ago like me, and you got some message about MSV CRT 11.dll is not found, and then you just sort of Google it and somehow find someone else's thing, and you drop it in System32 and it works, and then you try to forget that you ever did such a gnarly thing. Anyways, so this is basically the sort of system library that you need to be careful about building into your application if you don't want other people to have that same experience. So the artifact detail is getting bigger now, right? We're getting sort of less mobile but more compatible. We have a 30 megabytes artifact, and if you look at Dropbox, it's still under 100 megabytes, but they have a lot of code in there. It is OS specific, like I said, and it's going to be an exe or an app or something similar. For distribution, most commonly, you guys actually use this kind of code probably on a daily basis. There may be a Python frozen somewhere in your machine that you're using, and you probably just downloaded it, or you got it from the App Store. And this is a developing trend that's really concerning in some ways. App stores really complicate packaging for the developer. It puts the complication on us to protect the consumer, right? So basically, if you need to worry about signing, or if you need to worry about special formatting and that sort of thing, these freezers have to keep up with those App Store requirements. So if someone's directly downloading from your website, then you don't need to worry about having an icon and a summary and an XML file or something like that, right? You can just be whatever. But here, you basically have to have your freezer support that. It's complicated, and really bless those people who actually continue to maintain their freezers and make it work with those app stores. Okay, so freezers represent the best option for consumer software. It's a headache for us, but it's a really good thing and natural experience for most computer users, and it's a reality for most consumer Python software engineers. Now, you know that with something as complicated as that, there has to be an enterprise edition, right? So there is a freezer that I want to talk about that I got really excited about recently. It's called the Omnibus, right? So basically servers need extra attention. Servers aren't consumer software, right? And when you build a server application, man, does it have a lot of moving parts. When you really think about it, a 3-tier web application is going to have a database, and it's going to have an application server, and it's going to have a normal web server, and it's going to have batch jobs, and it's going to have a lot of things. And Omnibus manages to represent all of that in a way that's very similar to Anaconda. So it has a sort of self-containment in that it installs all under one directory under like var or something like that, yeah, something like that. You can see how it works. My favorite way to see how it works is you go just check out GitLab Omnibus. Have people here heard of GitLab? Okay, so I mean basically GitLab is like GitHub but better in a lot of ways. Very surprisingly, right? Count me very surprised by this, but their code review, it was better than GitHub when I started using it and has only gotten better since. And they have no reason to do that. They're the best Git code review open source thing that exists, but because they're open source, it just keeps getting better because people have to use it. I don't know what happened to Garrett, but somebody should tell GitHub about this open source thing. I mean, we can get the code review on GitHub better if they just, I don't know where, why GitHub doesn't do more open source. Anyways, so, but we have this high level of self-containment, and if we look in, I don't have it here, but usually I have a screenshot for what this looks like inside. It's pretty similar to Anaconda. There's an etc, there's a bin, there's all these sorts of things. So, check out GitLab's Omnibus. It's all up there. So our app on Omnibus would require a Debian or Red Hat-based Linux because it builds a deb or an RPM. You install it with something like Yum, something like apt, and it requires only minimal system libraries. So like Anaconda, your application will probably use the glibc of the host system, but all of the other libraries will be inside of that deb and RPM. The artifact is, for our little script, going to be less than 100 megabytes. And I think, their Omnibus, the Omnibus install for GitLab is a similar size. Big, but not too big. And yeah, so basically you just download it via the website. You can be Googling it now. And it's the easiest way to install GitLab, in my opinion. But you can also get it from like a PPA or some other package repo. And the nice thing, it works so well that like I can update the GitLab for the entire company by just using the normal RPM and deb flow for like Yum installing. And you get that nice transactional element of it, and it doesn't affect the host system. It's really, really sweet. So anyways, Omnibus could probably ship our little script, but like it works best for applications that have multiple components like those queues and batches and all those other things, It's a real-world piece of software, and it works really well. I can't speak to the rest of Chef, but the Chef Omnibus works really well. Okay, so by now, having like broached the topic of RPM and debs, you're probably wondering, like, what about these guys here? What about RPM? What about deb? What about virtual env? Why haven't I talked about those yet more directly? In my opinion, these are components. These are building blocks, right? They're more part than whole. And as if to demonstrate this, right, like there's a thing called DH virtual env that I think Spotify or someone built that more or less puts a virtual env into a, Debian package. And it's effectively analogous to Pecks. It relies on a system Python existing, right, and it just has the libraries and all those things in a relocatable single archive. And it works for them, Like I said, you don't need to go extreme here. You don't need to freeze your stuff to be the best. But like, you can make virtual env work, and it can work well. You just need to include it with other things, because virtual env doesn't include distribution, like Conda would. Okay. So, yeah, then you have your artifacts managed by your Debian package manager. All right, now we're getting hot here. We're getting trendy. We're getting into this thing called user space images. Now, up until now, I've always been drawing things back to how stuff can kind of leak to that host system. Libraries can kind of leak out. These user space images kind of fix that. They bring the whole user space, which is that file system I keep referring to. This is kind of like Anaconda, but combined with those auto-start CDs. I think people here probably remember, but like you remember, you could plug in a CD and you press it in, and it goes, and then you wait for a few seconds while it spins up, and then you get a little thing about like, hey, do you want to install SimCity 2000? And you're like, yeah, I love this sort of thing. Anyways, and so you have these auto-start CDs, and this is actually where user space images come from. They build on this ISO 9660 like format, and it actually mounts a whole like file system onto some part of your Linux machine, and it only uses components from inside that file system as far as libraries are concerned. My favorite example of this is the app image. And so there's a KD and Live video editing software, right? And it ships as one executable file, kind of like our Pecks. No install necessary. Just double click it and you open it and you can edit the video, you know. I'm not much of a video editor, but I did open it up in my terminal and I did look inside to see what it had. And because it's just like sort of an archive that you can open up. And if you look, you'll see the same thing. There's an etc file, there's an etc directory, there's a lib directory, there's a user directory that has a bin under it that actually has your software. And if you LDD stuff in here, it only refers to stuff inside of here. You know, it doesn't leak out to that host system. And it's one file and it's executable. What more could you want, right? Why don't we just stop here? Anyways, but basically, you can go try it out, KDN Live. If you have some videos to edit it, give it a shot. You can try user space images. Interestingly, it's kind of more just on the consumer side at the moment. I'll talk more about that in a second. For now, let's look at what our installation requires for our useful.py. It only works on Linux. And I downloaded it and I have to chmod plus exit, you know. But it is otherwise, you know, basically a very easy install. The artifact is less than 100 megabytes. Remember, I'm shipping basically a whole operating system at this point in terms of files, aside from the kernel, just the user space. And it's got an ISO to go along with it. So that's the format. Basically, the way you get this right now, there's no app store for it. It's not like a really big hubbub. You just download it from the KDN Live site. I guess you could also put it in a shared folder. You know, it doesn't exceed any like extreme file size limits. So basically, if you have Linux, an image is even better than Pecks, but for our case, it's pretty conservative. You know, we can rely on Python being there. But this, like, we can put it all into one image. All right. Now we're up to the really trendy stuff. Anyone here a big fan of containers? Yeah, some people are raising the roof for containers. Okay. Contain yourselves. Anyways, all right. So basically, what we have here is, you know, what I say is that these containers are supposed to be disposable, but they don't seal as well as they are like claim to be. But they are more or less exactly those same things. They're those user space images, like app image, but they also have sandboxing, right? And so, what is sandboxing? Basically, maybe you've heard of this thing called. Let's get it on here. Docker, right? Maybe you've heard of that. So like one thing that confuses a lot of people I explain Docker to is like there's these images and there are these containers, and the containers are like the process, right? But the image is the actual like artifact. And so now, having understood a little bit more about the gradient, you know that there are things like app image. There are things that, you know, predate Docker that were these user space images. And then what did Docker come in at? It adds sandboxing. That's the container, right? And it adds distribution, right? Because you Docker pull things. So they're not the only ones doing this. As it turns out, there's sort of a Debian RPM round 2 thing happening among the, you know, under the Docker radar. There's a thing called Flatpak and there's a thing called Snappy. And one is sort of more the Red Hat camp and one is more the Debian camp. But basically they do the same thing. And this is the thing that's going to make 2018 the year of desktop Linux, right? Like, you know, we're going to have app stores for Flatpaks and Snappies, and you're going to be double clicking, and you're going to be getting your stuff, and you're not even going to have to worry about glibc. So basically, this is the state of containers right now. So what does our app look like if we containerize it? So first of all, you're going to need Linux, right? Now, containers, much like app images and user space images, only work on Linux, or you have some virtualization compatibility layer. You need a container runtime as well. So with app image, maybe we didn't appreciate that enough because double-clicking was so easy. No runtime necessary. You get all of that self-contained artifact goodness just in your double-click. It's built right into the kernel. ISO 9660 has been built in for a long time. A lot of these other features have been built into the kernel for a long time. It just works. When we introduce containers, in order to get sandboxing and distribution, we also need to have a container runtime. It kind of complicates things, but maybe it complicates things in the way you want. Maybe it does. Anyways, because like there's this pull step, you gotta pull it. Maybe you run it and you just wait for a long time the first time. Now we're starting to get pretty big too. right? Like if you naively build a Docker image, then you know that you can like pull in a gigantic thing and build a 2 gigabyte image for a 3-line file. You could totally do it. It makes it very easy to do so. You know, another thing that's strange about these artifacts, much like the whole inclusive App Store experience, you don't see the artifact much. What format is a Docker image? It used to be ISO 9660, but now they do their own thing because they have a very complicated container runtime. I mean, for that matter, though, when you go on your phone and you install something, do you ever see the APK? No, the App Store handles it, right? The OS is handling it. They want that same glossy experience for you as a developer. They want to make you feel the cush in your chair and just sink in and let the Docker wash over you. Anyways, so for your distribution options, you can have a Linux App Store if you're Flatpak and Snappy, or you can have Docker Hub or run your own registry, right? And this is very bizarre, this Docker Hub thing, because people are building these 2 gigabyte artifacts and they're uploading them and downloading them thousands of times a day, like, and they're getting it for free, right? Like, I mean, no, it's got $180 million of VC in there, right? Like, this gravy train is running on some interesting stuff. But you could totally do it. You could make these gigantic applications, fill them up with torrents, and you know, put them up on Docker Hub on Docker's dime. Don't tell them I sent you. But anyways, yeah. So we could totally containerize the 3-line script, and it probably wouldn't even be the most ridiculous thing I've seen on Docker Hub. So, anyways, that's my piece about containers. Now let's talk about the venerated veteran, the virtual machine, right? So before, what we've done, you know, just to sort of recap a little bit, we've included our Python, and then we've included our runtime, and then we've included our user space, and now we're going to include the kernel, right? And we're going to include not just the file system, but we're going to include like the boot and everything. This is a result of, like, I don't know how many of you actually work at VMware and this sort of thing, but man, I have a lot of respect for the progress that has been made, because I used virtual machines early on, and it has gotten a lot better. This is some production grade emulation. I'm talking about the speed of the processor stuff. Like, you can have certain operations execute at near bare metal speeds. I think that lately VMs have gotten a little bit of a bad rap. And it's the key to the cloud, right? Before we had VMs, there was no real meaningful AWS. You know, you had tickets, you had to file it, right? And it was a problem if you. I look out there. I know a lot of you did some self-hosting in these data centers beforehand. So yeah, I've also illustrated a screenshot of an OpenStack deployment. It's a Python going up an escalator to a cloud. It's a data center cloud, not like a heaven cloud. But yeah, the cloud is alive and well, I'm sure you know. So let's virtualize our app. So wow, we can use any operating system to run our 3-line script. That's an amazing thing we can do. Oh wait, no, we need a hypervisor as well. But the thing is that, like, you know, basically you need this virtualization if you're doing Docker too. Don't look at me like that. So basically we have this artifact that is now on the same order as a Docker image, generally bigger. Like if you look at the curve, the bell curve, it generally tends to be a little bit bigger. The size isn't the problem here though. For a long time, the number of like formats was a problem, but that's gotten better. I think the biggest problem with VMs right now is that you still have to basically directly download them. You can use AWS hosting and OpenStack Glance and so forth, but there's no VM image app store, right? There's no VM image hub. No one is excited and VC enough about VM images right now to, like, you know, host all your images for free, right? Like, it's just not that hot of a technology, but it is a very solid technology. So it's way too unwieldy for a 3-line thing, especially with that distribution problem. But realistically, VMs are only getting more powerful. They are part of the foundation of how things run now. Don't malign them just because of past sort of complexity. Vagrant files, still not the worst thing if you have to use them. All right. Now, I don't know if you saw this option coming, but hardware is the king of software distribution, right? Like, you know, basically, don't forget, right, that like I, you know, can just ship you the box, right? And this actually is a really key part of the software industry. At PayPal, right, we had dozens of HSMs, hardware security modules, and we got them for the hardware, but realistically, we didn't need very advanced hardware. We needed specific software and specific, like, sort of APIs implemented in a hardware fashion. And, you know, we don't update those with pip. We don't update those with Conda. We don't update those with RPM. We definitely don't use Docker, right? Like, we have these hardware security modules, and they are what they are. They're appliances that sit on the rack. And so, yeah, appliances. This used to mean something special in the data center. Nowadays, you're getting a lot of software on your fridges and ovens and like other household things. So like appliances is losing its sort of technical meaning, and it's merging with the consumer meaning of appliances too. So there's a lot of software that just comes on hardware. Here are a couple of examples. So the one on the left is an enterprise router. I was just sort of Googling for Python software that ships as hardware, and this advertises itself as basically being able to take Python modules and plugins as one of its main features. You can customize your enterprise Wi-Fi. Not to scale, but on the right is a MicroPython, and that is a special Python like on sort of silicon in a way. It's a Python runtime and execution environment that has a hardware manifestation. So, at my current job, we have a hardware component to our work, and we have to ship, like, every time we want to do a new run of, like, hardware, we have to ship, like, stuff from China to us, and it takes a really long time, and we really don't want it to mess up, so we actually ship them a machine with everything they need to, like, actually manufacture our hardware. And that is the most foolproof way of getting our software to them. We don't want any mistakes to work. We ship the hardware to them. And then they ship the correct sort of beacons to us. So yeah, it's a high latency delivery, but it comes fully loaded, like our snail friend. So what does our 3-line script look like on hardware? It needs electricity, much like all of the other options. I forewent mentioning it, but all the other options need electricity, and this one is no exception. If you want your software to run on hardware, you need the zaps, the gigabits, the gigawatts. All right. As far as the size, right, I'm thinking maybe we make it like 4 inches by 3 inches by 1 inch, like something that fits nice in your hand, right? Something I can toss out there, can take a little beating. I'm thinking it could run like $50, you'd probably pay for it, right? And it would ship in like 1 to 3 business weeks, at least until like, we really get production underway. Distribution, USPS works, for inside the country. We got DHL if you want to ship to faraway places. Also, like I said, you just sort of toss it out to the audience. It's fun times. I'm thinking it could look like this, right? Would you get this, as soon as we launch the Kickstarter? Right, we have a built-in display, 4 USB ports. That's way more than a MacBook Pro these days. Anyways, we can ship Python as hardware. It would work, and it does work. We saw those routers and other like appliances out there. It's really cool. So, all right, we're wrapping up here. Taking it all the way back, the very first thing, packaging, is creating that distributable software artifact, even if it's hardware. The software is what you're getting. A packaging design is not the last phase of the project. That was the one I wanted you to walk away with, right? Make sure you pay attention to that packaging early on in the project. Don't leave it TBD till after you've written your code. Python is general purpose, and PyPI and pip are not. Those are for development tools. Those are for libraries. Feel free to ship your blogging engine via pip. For other developers, right? But as soon as it comes to something for consumers, you have to think more about it. And that's because libraries are different than applications. These are the key lessons. So, now to recap our options for shipping this is where you get to see the gradients. I spent a lot of time in Google Slides making some nesting circles for you. Basically, the simplest option for shipping libraries is a py file, the standalone module that only imports from the standard library. You determine what version of Python you're targeting. If you're targeting 2.6, 2.7, 2.3, right, both 2 and 3, 3.7, an Anaconda specific build, whatever. You decide what the standard library is going to have, and then you build to that. You have sdists. Those ones are the tar GZs that include Python files, and as long as it's pure Python, it's just going to work. And then you have wheels. If you have binary artifacts, do your downloaders a favor, don't require GCC on their machine. In most cases, build a wheel for them. And then there's sort of a, it's not represented here, but there's kind of a gradient within the wheels of like whether you want to do a very dynamic build and require a lot of system libraries, or whether you want to statically compile a lot in and only rely on, say, glibc and libpython. Here's the big daddy, right? Here's your packaging for Python applications gradients, right? At the very heart of it all, you have the Pecks, and that has your libraries included. Then you can do Anaconda, which gets you libraries, a Python, and other kinds of applications. You have freezers after that. That includes the Python into the artifact. Then you move on to have images, right? Those are those user space images, those Docker images, right? That's the system libraries also included, right? So you don't leak anything out to the host system. Then you have containers, which take those same images and sandbox their runtime and give you a distribution mechanism. Then you have virtual machines, and that's how you get the kernel involved. You want to run, you just, hate Red Hat so much, you want to run Ubuntu, like on that machine. Virtualization has got your back. And, run Windows on Linux for all I care. Anyways, and then you also have hardware, right, which basically is plug and play, right? You just plug it in, grab that electricity, and you're good to go. So, it's been fun, guys, but this time it's a real ending slide. Now if you have any questions about shipping Python applications, I'm happy to answer them. But first, let me catch my breath. What do you call it? Round of applause? Thank you. All right. So we got questions about shipping Python applications. I'll put this one up. It's a good illustration. All right. Yes, over there.
Install most of the dependencies, like take the publicly available ones, but I have some private code.
Yeah.
What do you recommend is the best way to post packages that integrate with Conda?
That's a really cool idea. So basically at PayPal, one of the last sort of like iterations of our packaging solution looked like having a bunch of tarbz2s vendored in effectively as part of the build process. And so we had an RPM that had a bunch of Conda packages inside of it, and it installed a mini Conda and Conda on the install. It took a little while, but it worked really well. Another option that you can do is that Conda actually has built in the ability to generate indexes. And so you can self-host your own Conda index, and in your own like data center or whatever, right, you can run one of those. Because one really cool thing about Conda and that differs from pip, a lot of people, maybe it didn't come through clear enough here, is that pip, you have to basically install one package, look as it set up PY to see what it depends on, to look inside of those set up PYs to grab those. Conda's not like that. Conda, you specify all of the metadata in a structured format that allows it to pre-compute all of the versions you need ahead of time. So much like RPMs and debs, you can actually get a summary up front, what I'm going to install. And so you can, basically you need Conda to build that package metadata to run your Conda index, but like it is built into Conda. Yeah, no problem. Yes?
Over some aspects like the user being verified.
Mm-hmm.
The source and authenticity of the package, you mentioned that very briefly.
Sure.
Talk about more of the containers and the sandboxing, where the sandboxing can be more restrictive in a particular environment where it's running, not necessarily developer defined.
Okay, so I guess the question is a little bit about like how do you run code safely, right? How do you run these artifacts safely, and like basically in those install environments, like verify that you got the right artifact. So there are a lot of solutions here, and different Docker registries are going to support different things. But in short, like I don't trust Docker farther than I can throw its artifacts. Like basically, if you run as root inside that container, there are way too many things that like say UID1 and like PID1 and UID0 and all these things. Like basically there's like a vulnerability a minute. I don't really trust Docker for its security aspects. And in fact, if you read their docs, they don't either. The salespeople will tell you something else, but like the docs say, don't run as root, don't run as root. And yet like when you use the APIs, it sort of pushes you toward running as root. Now, as far as verifiability, like, RPMs and devs have a really, well-developed story for package signing and, the whole web of trust and that type of thing, PGP keys. As far as you can, I actually, like, our Kubernetes, we're, like, spinning up Kubernetes and stuff like that now. I mean, there's some, like, validation that you can do when you're installing the Docker images and make sure that they're the right ones. But oh, okay, sure. No, that's actually that's a great point. So if we're talking about something beyond containers, like with Pexes, right? Like basically what you do is you have to separately distribute a hash, like an MD, not an MD5, but something like an MD5. Anyways, like a SHA-512 if you want. So a hash is a good way to validate that, but you do have to build it yourself because remember, there's no installation process, there's no app store for it. With Anaconda, I actually don't know if they support like native validation of that sort of thing. I would believe that they do, though. They tend to add features really quick. With freezers, remember that's what I was saying, app stores are becoming really important. We want to protect the consumer against exactly these sort of things, so signing and those special formats are what protect the users in consumer software cases. In the Omnibus case, you can do package signing because it ships as a deb or an RPM. So each of these has its own story for it. Kind of, I guess the dream is that like among these container upstarts is that they would have a better story for it. But there are other security issues there that I think are more pressing. If you run a private registry, it's within your data center and it's all firewalled off and so forth. It's Oh yeah, reproducibility is really important for all of these. Sure. I mean, reproducibility in builds is like the goal, right? This is about packaging, not specifically about build, but reproducibility is key. And Anaconda and Conda was founded on that as a principle, right? They had all these scientists, right? Like, actual scientists, not just data scientists, real chemists and biologists and neurologists and so forth that were like pip installing, how these scientific libraries with all different compiler flags and getting different results. Right? But if you get the binary distribution, you're going to get the same result if you have all the same things. It's computers, right? It's supposed to be deterministic. But if you have enough complexity, it ends up being kind of organic and sort of a little bit variable. And that's not really what you want for the reproducibility of science. But Anaconda has that specifically in mind as a story. As far as, internally, like how to get a reproducible freezer build, you'd have to talk to someone like, Dropbox, or there's this one guy, James Abel, who comes to Peninsula meetup, and he wrote OSNAP, so he has a lot of research on that too. I'm going to go back, sir, and there's going to be Nuitka on that list.
Yeah. Talk about a little bit of the reproducibility of outcomes of science.
Yeah.
If you have an application like machine learning or something that melds in data into your application, let's say it's 90 gigabytes in size, where do you think that falls?
Okay, so the question is, what do you do if your application relies on like some form of large data? Now,
Let's say it's got to be kind of 5, 10 years and still on data.
oh, okay. So, I mean, he's mixing it up. He's even making it so that the data is like kind of, Sure. So basically, if you have data for scientific purposes, right, there are all these data hubs, right, that give you effectively like kind of a data warehouse-ish type thing that allows you to archive those and share those data sets. And there are several of those, many of them with the same goals as Anaconda in mind that work with Continuum people. And I think that some people presented on that at PyCon too. So it's a great question, but other libraries, the data doesn't necessarily have to be big in order to have this problem. There's a library out there for doing geolocation of like IPs, right? And you can pip install it, but it doesn't come with the data because obviously that data is going to be going out of date every month or two, sort of fading away in accuracy. And what that does is it has kind of like just document of like, here's how you have a cron job, or here's how you reload data. And you have sort of background thread that pulls it every now and then when it gets updated. So a lot of these things, you don't build that data in if the data isn't really part of the software. You have a separate host for it, and you can cite that too. They have little citation generators for those data hubs. Yeah, no problem. Questions? Python applications. How's it going? Mm-hmm. Sure. So I can't speak too much to Android, but the question was, what do you do about security and verifying the host system that you're on? This is a big research area. There's like, at some point you just have to trust. But that's one thing that I wanted to make a slide for, but didn't have the time. The more, like that trade-off of like the bigger artifact, right, and the more portable, or sorry, more compact artifact, as you get bigger, you also tend to get less flexible, right? When you're depending on that host system, right, it's not necessarily a bad thing, because if I depend on the host system for OpenSSL, right, and then somebody runs an update and they update OpenSSL to patch a vulnerability, all of a sudden my app, also gets that OpenSSL fix. So it's kind of an administration trade-off, right, that you have to decide. The biggest artifact doesn't necessarily win. The hardware is much harder to update that sort of behavior than a Pecks, that relies on the system OpenSSL. As far as the poisoning of the entire host environment, some interesting stuff in this area. Like you can do like a signed package and then rely on TPM, like the actual processor, to have a trusted computing environment. Yeah, it seems on Intel only. Okay, I mean, I don't do a lot of ARM, I'm afraid. But there are trusting. Oh, like phones? Yeah, I mean, they're trusting. Trusted computing is like a real big research field right now. And unfortunately, I have to say that in terms of priorities of the industry, it seems like in all the places around here, anyways, they want to focus on velocity, shipping software faster. And they kind of sacrifice a little bit in terms of security. I mean, Equifax is out there with years-old struts things. I mean, I don't know. Just with straight up remote execution, I don't know. We're in kind of a dire spot. But trusted computing is a really good area to discuss in terms of packaging. There's really cool solutions, but they're oftentimes very custom. There's no security plugin. Question in the back? Okay, yeah, so the question was, if you didn't hear it, basically what happens if you statically link something you shouldn't have and then Python was dynamically linking in something. And I think that, I mean, it doesn't happen that often because I've been admonished against it so many times, but you can get symbols, crashing together and then it just doesn't run. If when you import something in Python and it fails, you get a pretty good error message relative to what happens. And if you dynamically link in something that fails, you'll just get a seg fault or a bus error or something very non-descriptive, and you have to pull up a debugger, like a GNU debugger or something like that to get to the bottom of it. So yeah, it's definitely something to avoid. Don't be careful about statically linking in too much stuff and then just assuming it's going to work in all execution environments. All right, folks. I guess there's one more. All right.
Talk about just the difficulty level of packaging your app for, say, Anaconda versus Omnibus versus, say,
Yeah, absolutely, absolutely. So this was a difficult decision I had to make for this extended version because I considered doing sort of mini demos of each of these, right? I considered basically, not live ones, right? More fake ones for you. But but basically screenshotting what it's like to build it. And you know what's weird is that as I was doing that, I realized that some of these systems are built for demoing and some of them aren't. you know, and the micro solution of basically my 3-line script isn't representative of actually shipping an app. So I can package that little app with my Pecks thing like in one command line thing. It's really like easy. But the thing I use at work to package that for reproducible builds and an actual production Pecks packaging thing is much larger, and there are 2 CI jobs involved, you know, to actually get the artifacts into the right distributable positions. So, I mean, each of these, I guess what I'll say is that none of these for a production application is going to be a walk in the park, right? Packaging is always this sort of stretch, this last stretch. That 90-90 rule doesn't go away just because you know about the existence of these. Each application is custom in some way, right? And so I would say that Pecks ain't too hard. Anaconda, I mean, if you're just asking like my gut about, since using all of these, right? Pecks is pretty nice. If your thing fits into a Pecks and it works for your application, Pecks is pretty nice. It requires a specific version of setup tools, right? And it still has some problems with wheels, but the GitHub issues are there. You can see what the implications are. Anaconda is pretty okay, kind of underdocumented, surprisingly. But the good thing about it is because so much of it is open source, you can just go to Conda Forge and see how they package other things and copy and paste and get a lot of stuff working there. So I would say that if your application looks like any of the applications that are currently Conda installable and on Conda Forge or something similar, you're actually in pretty good shape. It wouldn't be too hard. Freezers is where the headache is like greatest, right? Especially because testing consumer software is so hard. It often means you just need to have lots of laptops, you know? When it comes to the images, bare images like app image are still kind of, they're not developing as quickly because it's a much smaller community. There's not like an app store. There are only so many large applications that are shipped as this. It's basically not used in the server domain at all. I think that's one area people should explore more. But that said, like, you know, if you have a Linux application, you don't need to test on too many desktop Linux environments to get a good sense for like the fact that it works. You target Ubuntu, you target Fedora, you target just LTS releases, and testing is not so bad. As far as the containers, because you're including the whole user space, and as long as you know you have a new enough kernel, basically you can, it's pretty reliable. You don't need to test it too much. But that said, I find that containers are far oversold in their terms of actual like utility and usability for a full-blown production application. It seems to be that you will always run into a problem, and then you Google it, and then you end up on a GitHub issues page from 2013, right? That basically you scroll down to 100 comments, and then it says closed in favor of this, and you scroll down that, and then it closed in 2015, closed in favor of this. You scroll to the bottom of that, and then you see a comment left 3 hours ago, like, why is this still broken? So, So I think we all know that, and we had a good Docker, the good, the bad, and the ugly kind of confessional talk at my meetup like a couple of months ago, and it was like a Dockerholics Anonymous type thing. Everyone's just like, you know, everyone says there's all these problems, but then everyone makes it seem so easy. At the same time, there's a lot of hype, right? And so I wouldn't get overly drawn to that. Part of my goal in this is saying that, look, there are a lot of options. Pick the one that's right for your solution. Containers are way overkill for most solutions, right? You have all these other ones before it. As far as virtual machines, I mean, you can just, bam, image something and like have it work, right? So like, that can be pretty nice. It's kind of a headache to maintain though, constantly like, making new images. Vagrant helps with that a little bit, but we all know Vagrant's not perfect either, and that's, it had a lot of hype at one point too, but now I think that the industry impression is more reasonable. And, hardware is a big headache. You know why hardware is such a big headache? I had friends that had that Kickstarter that did that sort of thing. And what happened was they had something actually cool. They gave a TED Talk on it. And Hasbro saw the TED Talk, knew who would manufacture it as a result, went to them under the table, said, we're going to give you a much bigger contract for exactly the same thing, beat my friends to market, right? And just completely like, flattened that market out for them, right? So basically with hardware, it's like you better have a very good software running on it, right? Because when as software engineers, we feel a very cushy life. The actual hardware engineering life is very physical. It's very much like, flying to Shenzhen and like making contracts and signing things and like going eating like jiaozi and this sort of stuff. So like, it's hardware is real. Playing around with an Arduino is kind of cool, but make sure you have really good software and not just a neat hardware concept. Whew. All right. Does that sort of answer the question? All right, cool. Well, it wasn't a short one, but it was a fun one. Thank you for that. I'll be around for a little while longer. If you want to come up and talk more about packaging, I'm happy to. But yeah, I just want to say thank you all for coming. You've been great. Yeah, thanks, Jeff. Oh, and if this is based on a blog post, by the way, and you can visit that blog post at this URL that is as short as I could make it.